Good day, everyone. Thank you for joining us today. Our presentation will focus on practical machine learning project sentiment analysis on Amazon reviews. This analysis, as you will see, allows us to delve into the thoughts of the customers, providing us with actionable insights on how customers view each product. So, sentiment analysis plays a crucial role in understanding the customer opinions, identifying strengths, weaknesses of the products, and making data-driven business decisions. So, our objective is to develop a sentiment analysis model using machine learning techniques to automatically analyze and categorize the sentiment of Amazon reviews. Okay, so now let's look at the research steps. So our research steps involve the collection of data set of Amazon reviews, and we have to make sure that the data set we have has a wide range of sentiments expressed by the customers on wide range of products. Then the second process is to pre-process and clean. So this involves removing stop words, emojis, punctuations, uh, converting the sentences into words using tokenization, etc. And then the third step is to develop the sentiment analysis model using machine learning algorithms such as naive Bayes, support vector machines, recurrent neural networks, etc. And the third is evaluate the model's performance and accuracy. And the last one is extract meaningful insights from the sentiment analysis results. So to give a background, like why sentiment analysis is required. So sentiment analysis is required because it helps us understand the customer's opinions. It enhances the customer experience because if the customers are, if we are able to figure out, okay, the sentiment of most of the reviews on a product is negative, then the seller or Amazon can rebrand that product or relaunch that product or make it maybe the delivery it's not getting delivered on time, or the delivery package is not is I mean the delivery items are broken, so Amazon can work on that. Then second is the third one is monitor brand reputation. So like I said, same as before, like if you can enhance the customer experience, if you understand the customer experience, then you can definitely monitor your brand reputation. And also competitor analysis. This can be done by the sellers who are selling on Amazon. Different sellers sell the same product, but if the sentiment on one of the seller is high than the other, then they can see like what is going wrong, where are they lacking, and things like that. And the third is like inform marketing and advertising strategies. So by analyzing the Amazon reviews, business can identify positive aspects that can highlight it into marketing and advertising campaigns. And then the last one is you can make data driven decisions whether this product works for us or not. So let's look at the data overview. To perform sentiment analysis of Amazon reviews, we collected a comprehensive dataset from Amazon platform, Amazon US electronic review dataset. The dataset involves like 2,800 records for training, 1,200 records for testing. It's a balanced distribution of sentiment categories. So the dataset allows us to train a sentiment analysis model and evaluating its performance in accurately predicting sentiment. The balanced distribution of sentiments ensured a representation of positive, negative, and neutral reviews. And the primary focus of this was to get a good accuracy score. So let's look at the exploratory data analysis, which is distribution of data. So this is the data distribution. So the data we had were having like major reviews were like 5 stars. Then second contribution of 4 stars. Then 1 star was the third. 3 stars were second last, and 2 stars were the least in the distribution. So because like this is kind of a skewed data, so uh, we modified the data into this. Like we said that okay, so customers having 4 or 5 star means that these are the positive positive sentiment, and the reviews which are having 1, 2, or 3 star are negative data, negative sentiment of the data. So now my colleague Binay will talk about the first model, which is logistic regression using NLP pre-processing. Thank you.
Next up is the sentiment analysis model. This slide shows the sentiment analysis model and the techniques we have used. The feature extraction technique used here is TF-IDF. We have used logistic regression model and Distilbert model to do our analysis, and we are using accuracy as our metric for the model training and evaluation. After that, we have the slide and logistic regression performance, which is our first model. This approach include using logistic regression model from sklearn library, which is a popular machine learning algorithm for binary classification problems. We chose logistic regression because of its simplicity and its efficiency. It is a common model in text analysis. As part of pre-processing, we used several standard natural language processing techniques using the NLTK library to prepare the data. These steps, while seemingly basic, are crucial in preparing text data for modeling. We converted the text to a lowercase to maintain uniformity and eliminate duplication based on case differences. We then tokenize the text, breaking it down into individual words or tokens. Further, we applied stemming techniques to reduce words to their root form. Lastly, we removed stop words, common words like is, at, which, and on, as they often add noise rather than value to the analysis. We will come back to this technique at the end of the presentation. Once we had our reviews cleaned and processed, we needed to convert the text data into numerical format that our model could understand. For this, we used the TF-IDF vectorizer from sklearn. TF-IDF is short for term frequency inverse document frequency. It is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. By transforming our data into this numerical form, we were able to feed it into our logistic regression model for training. Logistic regression model eventually produced an accuracy of 0.625% on the testing data set, which is like 62.5% on this Amazon review data set. Model 2, fine-tuning Distilbert model. Now we moved on to a more advanced model. For this, we used Distilbert, a compact, lighter, and faster version of BERT, the state-of-the-art model in natural language processing domain. One significant advantage of using pre-trained model like Distilbert is their ability to leverage previous knowledge learned from extensive data, often improving model performance slightly. The library used for this model is TensorFlow 2. Before fine-tuning Distilbert, we pre-processed our data using Distilbert tokenizer. Fine-tuning transformers requires a small learning rate, which is the rule of thumb on the scale. And the rule of thumb on the scale is 1 to the power minus 1 into 10 to the power minus 5. The best one that works for this project is 5 into 10 to the power minus 5. We experimented with a few optimizers, ADAMX, both are working fine. As before, the evaluation metric is accuracy. Due to the size of BERT model and computational resources at hand, we fine-tuned the training data set in 2 epochs. After fine-tuning and testing Distilbert on our data, we noticed a significant improvement in performance. The model achieved an accuracy score of 0.87, a substantial leap from our initial logistic regression model. This demonstrates the power of advanced transformer-based models in extracting more complex patterns and delivering superior quality results in sentiment analysis tasks. In this slide, we are showing you the demo with the fine-tuned Distilbert. Because of the intensive fine-tuning process, we saved the fine-tuned model weight. We did 2 simple demos to demonstrate the model performance. Both demos were correctly classified, as you can see in the example in the slide. The first example is the review. This is a good item which is correctly classified as positive, and the review this item sucks is correctly classified as negative. This slide shows the comparison of results. As you can see on the screen, we have the accuracy for both of the models. Logistic regression has an accuracy of 0.62, while the Distilbert model has an accuracy of 0.87. Distilbert model seems to have a better accuracy than the logistic regression model, and the main reason for this is because Distilbert model is a contextualizer, thus um, meaning obtained from the sequence of word in a sentence is somewhat preserved. Next up is Model 3. It is using GPT-4. GPT-4 is the state-of-the-art language model by OpenAI. It is trained on diverse text sources for broad language understanding and is able to generate coherent and contextually relevant responses.
Um, as of right now, we have covered two models. One baseline model, logistic regression model to classify sentiment. One Distilbert model, a fine-tuning on top of the popular transformer model. And this model significantly improve our accuracy. We didn't stop there. We further experimented with GPT-4, the fourth iteration of a generative pre-trained transformer model. And GPT-4 has been making wave in AI community due to its very impressive language generation capability. We conduct a few trials on the sample selected reviews using GPT-4, while some trials showed mixed result, which is on this slide, and hovering around the same level accuracy as Pearson models. And we had a breakthrough in one trial, and where model achieved the full accuracy. And this is the one we are showing. And the prompt we use is fixed in place to make sure each time the prompt is consistent. The prompt we use are as follow: perform sentiment analysis on the input delimited by triple quote, and return the result in JSON format with two keys. One key is input review text, another key is classification result, either positive or negative. And then we convert our result positive label as 1, negative label as 0, and this will be easier for evaluation. However, it's crucial to note that these are the initial tests, and we already seen the instability, and more extensive tests is needed to fully evaluate the effectiveness of GPT-4 and for this task. And in this context, GPT-4 is not ready for any serious production environment. Now let's talk about the future work. Right, despite this promising result with larger language model, we realize there are areas of improvement in our current methodology. One of these concerns is the removal of negation stop word, such as none or not during sentiment analysis. These words are crucial in determining the sentiment of a given sentence review, as they can entirely reverse the sentiment expressed. Traditional NLP and state-of-the-art BERT models and both suffer from this. BERT model perform better, and mainly because it's a contextualizer model as well, and it can preserve the context, where the removal of negation word can lead to misinterpretation of reviews and affecting the performance of the models. Addressing this issue will form part of our future work. We aim to refine our pre-processing strategy to better handle such negation word and thereby improving accuracy of sentiment predictions. And this brings us to the end of our presentation. We hope this has given you a clear insight into our project and the exciting potential of sentiment analysis in understanding customer feedback on products. We are open for any questions you may have. Thank you.
Any questions or comments?